Assalamualaikum warahmatullahi wabarakatuh. My name is MuhammadSyahrilbinJamsuri. My metric number is 121282. So today I will be presenting my project, which is socio-economic determinant on total fertility rate, impact of adult female literacy rate, infant mortality rate, GDP per capita, and current health expenditure on total fertility rate. For the background of the study, the total fertility rate, TFR, serves as a crucial metric reflecting societal dynamics and influencing population trends. TFR representing the average number of children a woman is expected to bear during her lifetime, encapsulates the intricate interplay of cultural, social, economic, and health factors. This research project seeks to unravel the complexities surrounding fertility patterns by focusing on key variables, including adult female literacy rate, infant mortality rate, GDP per capita, and current health expenditure. In doing so, it aims to contribute valuable insights into the factors influencing population growth. For the research problems, the exploration of TFR determinants brings forth several compelling research questions. What role does adult female literacy play in shaping fertility choices? How do health indicators like infant mortality rate and current health expenditure influencing TFR? Does the economic landscape, as measured as GDP per capita, correlate with fertility pattern? This research addresses critical gaps in our understanding of the nuanced relationships between socio-economic, cultural, and health-related variables on TFR. Johnson et al. 2014 explores the mechanisms behind the link between education and fertility. They highlight how education could increase knowledge about health and reproductive health options, raises women's income and bargaining power within families, delays marriage and childbearing, promotes smaller family size preferences. Next, in 2023, visualize the relationship across various countries. Notably, some developing nations with high IMR, which is infant mortality rate, also exhibit high TFR, possibly due to cultural factors emphasizing large family, limited access to family planning, and short birth intervals following infant loss. Increased wealth promotes quantity-quality trade-off. It means that parents choose smaller families to invest more resources in each child's education and well-being. Next, cost of children. Raising children becomes more expensive due to increased living costs and education expenses, discouraging largest family. This is from Webkey et al. 2013. Next, Aston et al. 2008 studied data from Mexico and found that improved child health due to healthcare interventions could lead to higher fertility in the short term, particularly in rural areas with strong traditional childbearing values, particularly if access to family planning is limited. And then for the last one is Ashraf et al. 2006 examined data from 122 countries and found that increased public health expenditure, particularly on maternal and child health, was associated with lower fertility rates. This further supports the link between improved healthcare and smaller family sizes. This study aims to analyze the socio-economic determinants of total fertility rate using cross-sectional data. After reviewing the literatures and studies from previous researchers, the present study focuses on 4 socio-economic factors, namely literacy, which also same as adult female literacy rate, infant mortality rate (IMR), GDP per capita, and current health expenditure. Ordinary least square or LS estimation techniques was used to analyze this relationship. The data source for this study were based on secondary data and were taken from World Bank data for the year 2019 and consists of 72 countries. To achieve the objective of the study, the following level econometric model has been developed. TFR is equal to beta naught plus beta 1 literacy plus beta 2 IMR plus beta 3 long GDP plus beta 4 long health plus mu, which is mu is equal known as error term. And from here, we know that TFR is the dependent variable, which is total fertility rate, and for the independent variable, which we have literacy, which is adult female literacy rate, IMR, infant mortality rate, GDP, long GDP, natural log of gross domestic product per capita, GDP, right? And then long health is natural log of health expenditure. The following are the definitions for each variable stated above. So for the first one is total fertility rate, which is TFR. This measures the average number of children per woman. Adult female literacy rate, which is literacy, the percentage of women aged 15 and above who can read and write simple statements about their daily life with comprehension. In general, numeracy or the capacity to perform simple arithmetic calculation, it is also included in literacy. Next is infant mortality rate, IMR. Infant mortality rate, IMR, this measures the number of deaths among infants under the age of 1 year per 1,000 live birth. Next is GDP per capita. This is the GDP divided by the mid-year population, where GDP is the total value of goods and services for final use produced by the resident producers in an economy, regardless of the allocation to domestic and foreign claims. Next is health expenditure. Current healthcare expenses per capita is measured as percentage of the GDP. Healthcare items and services consumed during each year are included in estimates of current health expenditures. Next, we move to chapter 4, which is the results. For the first part is descriptive analysis. The table shows the data of total fertility rate, which measures the average number of children per woman falls between 1.14 to 7.023 with a range of 5.88. The mean value of TFR is 2.87, which indicates the average value of the TFR, while the median is 2.43. This indicates that TFR data doesn't have symmetrical distribution, as the mean and median values have the difference of 0.44 and the skewness is 0.88, which is the data for TFR is skewed to the right. As for kurtosis, the distribution of TFR is platykurtic with a value of 0.18. It shows that the dataset has a lower tail than a normal distribution. The result also shows that this data is less scattered with a value of 1.79 for sample variance, while the standard deviation indicates that the TFR is spread within 1.34 standard deviation from the mean. The standard error of 0.16, which is relatively small, gives us an indication that the mean is relatively close to the actual mean for the overall population. For independent variables, the data for adult female literacy rate, which is literacy, falls between 26% to 100%. Data for infant mortality rate, IMR, is between 2% and 85%. Data for log of GDP falls between 7.11 and 11.52, and data for current health expenditure, which is LONHEX, is between 4.17 to 8.32 with a range of 0.74, 0.83, 4.41 and 4.15 respectively. Next, the average value of adult female literacy rate is 0.82 and the median is 0.93. This indicates that the countries studied have level of literacy in the countries studied are quite good. For log of gross domestic product per capita, GDP, the average value is 9.25 while the median is 9.38. This also indicates that level of GDP in the country studied is quite good. Next, as we can see, this data literacy, GDP and HEX appear to be negatively skewed as the median is greater than mean and the value of skewness is negative 1.39, negative 0.1 and negative 0.06 respectively. However, for the data infant mortality rate IMR has a mean value of 0.23 and a median of 0.14 for IMR, which is the value is very close. The value of skewness 1.18 for IMR, also signifying that IMR is positive skewed. As for the kurtosis, the distribution of all independent variables are also platykurtic due to the kurtosis value less than 3. Platykurtic indicates that the dataset has a flatter tail than a normal distribution and may lack outliers. For the data variability, all the independent variables have low values of sample variance. For literacy, IMR, GDP and LONHEX at the sample variance of 0.05, 0.04, 1.07 and 1.36 respectively, indicating that there was small and almost zero and accepted value of dispersion in the data. The result also tells us that the data for literacy, IMR, GDP and LONHEX are spread only within 0.21, 0.2, 1.03 and 1.17 from their mean. This indicates that all the data are closely to their mean. As for standard error, the values of 0.03, 0.02, 0.12 and 0.14 for literacy, IMR, GDP and LONHEX respectively are relatively small, which gives us an indication that our mean is relatively close to the actual mean of the overall population. For the next part is correlation matrix and VIF. Table 2 shows the correlation among the dependent and independent variables. Correlation coefficient that lies between plus minus 0.7 and plus minus 1 is said to be strong correlation. The finding shows that the total fertility rate measured as average number of children per woman, TFR, is highly correlated with all independent variables. TFR are highly correlated with literacy, IMR, non-GDP, and non-HEX with values of negative 0.78, 0.85, negative 0.82, and negative 0.82 respectively. This shows that both TFR with each of these independent variables are strongly correlated and depending upon each other in a negative way for literacy, non-GDP, and non-HEX, and in a positive way for IMR. Negative correlations indicate that any increase in those explanatory variables will result in a decrease in TFR and vice versa. For the relationship between each literacy, IMR, non-GDP, and non-HEX, we can see that the correlation values are above 0.7. It shows that they are quite strongly correlated with each other. If you look at the value of variance inflation factors, VIF, which tell us how much the variance is inflated due to the multicollinearity, a VIF of 1 indicates no multicollinearity, meaning that the variance of the estimated coefficient is not inflated at all. As the VIF increases beyond 1, it suggests an increasing degree of multicollinearity. Typically, if a VIF values of 5 or 10 is considered a threshold beyond which multicollinearity is considered concern. From the table, we can see that all the explanatory variables, which are illiteracy, IMR, non-GDP, and non-HEX, have the values of VIF beyond 1, which are 2.51, 3.547, 3.02, and 3.054 respectively, indicating us that there is an increasing degree of multicollinearity within the variables, but they are acceptable value. Next, we move to simple linear regression analysis. Okay, from the table, we can make an equation which is TFR head is equal to 6.843 minus 4.845 literacy, which is n equal to 72 number of samples, and r square is 0.602. Okay, the model is quite performed in terms of F statistic based on the hypothesis that all variables are jointly significant. The result illustrates that this model highly significant as the value of F statistic is 105.67. In addition, the size of adjusted R square in the model is moderate, which explains that 59.6% variations in the total fertility rate are explained by the adult female literacy rate. This also explains that 59.6% of the data fit the regression model, while the multiple R of 0.776 in the regression tells us that multiple correlation between the dependent variable TFR and the literacy are quite strong. Moreover, the standard error value for this model is quite high, which indicates that on average the observed value falls 0.85 from the regression line. The estimated model shows that fixation of this independent variable to 0 will increase the total fertility rate measured as average number of children per woman to 6.843 unit. Analyzing the regression coefficient individually and apply first order condition, which is DTFR head over D literacy, we will get negative 4.845, which shows us that the coefficient of adult female literacy is negative 4.845. This indicates that 1% increase in percentage of adult female literacy will result in 484.5% decrease in average of number of children per woman. The sign of the slope coefficient of literacy, which is beta 1 head, is negative as it fulfills our expectation because the correlation between TFR, which is dependent variable, is negatively correlated with the explanatory variable literacy. For the next part is multiple linear regression analysis, MLR. From the multiple linear regression analysis table, we can make an equation which is TFR head is equal to 6.41 minus 0.256 literacy plus 3.162 IMR minus negative 0.266 non-GDP minus 0.254 non-HEX, and n equal to 72 and r square is 0.783. The model performed quite well in terms of F statistic based on the hypothesis that all the variables are jointly significant. The results illustrate that this model is highly significant as the value of F statistic is 60.50. In addition, the size of adjusted R square in this model is quite high, which explains that 70% variation in the total fertility rate TFR are explained by the attempted explanatory variables, which are literacy, IMR, non-GDP, and non-HEX. This also explains that 77% of the data fit the regression model, while the multiple R of 0.885 in the regression tells us that the multiple correlation between the dependent variable and the 4 predictor variables are strong. Moreover, the standard error for this model is quite high, which indicates that on average the observed values falls only 64.2% from the regression line. Next, we find that the intercept in the TFR indicates that if all the explanatory variables take on the value of 0, the mean of TFR will equal to 6.41. This show that precision of these independent variables to 0 will increase the total fertility rate measured as the average number of children per woman to 6.41. Analyzing the regression coefficient individually while kept the other variables held constant and apply the first order condition, which is the TFR head over the literacy is equal to negative 0.256, which means the coefficient of adult female literacy is negative 0.256. This indicates that 1% increase in percentage of adult female literacy rate will result in 25.6% decrease in average number of children per woman. Next, infant mortality rate IMR seems helpful in checking the impact on infant mortality rate by applying first order condition of TFR with respect to IMR while kept the other variables constant, which is status paribus. The coefficient of 3.162 indicates that 1% increase on infant mortality rate IMR will increase 316.2% of average number of children per woman, which is TFR. Log of GDP per capita, which is non-GDP, plays a significant role in reducing infant mortality rate, as was hypothesized in the research hypothesis. By applying first order condition of TFR with respect to non-GDP while kept the other variable constant, the coefficient of the variable non-GDP disclose the fact that it has negative significant impact on TFR. The coefficient of negative 0.266 indicates that any increase in non-GDP by 10 unit will bring about 2.66 unit decrease in average number of children per woman, TFR. Lastly, the variable of current health expenditure measured as percentage of GDP. Alright, LONHEX is included in this model to see its impact on total fertility rate. By applying first order condition of TFR with respect to LONHEX while keep the other variables constant, the estimated coefficient for LONHEX is negative 0.254, indicating that 10 unit increase in LONHEX yields a 2.54 unit decrease in average of children per woman, TFR. For the next part is research hypothesis. For the first independent variable, which is adult female literacy, the null hypothesis is the slope coefficient of literacy is equal to 0, while the alternative hypothesis is less than 0. Adult female literacy rate has a significant impact on average number of children per woman, which is TFR. The impact of literacy on TFR is negative. When we run the MLR, we could see that the literacy is not statistically significant at all significant level, which are 10%, 5%, and 1% because the p-value is 0.741. Higher than 0.1. We don't have enough evidence, statistical evidence, to reject the null hypothesis at the 0.1 significant level. However, there were some studies that confirms a negative significant and negative association between female literacy and total fertility rate. Bloom and Canning 2000, who found that literacy empowers women, expand their life choices, and potentially reduce their perceived need for a large family. For the second independent variable, which is infant mortality rate IMR, the null hypothesis is slope coefficient of IMR is equal to 0, while the alternative is more than 0. Infant mortality rate has a significant impact on average number of children per woman, TFR. Increase on IMR will grow the TFR. From the result of regression analysis, we could see that IMR is statistically significant with p-value of 0.001. Hence, we can reject the null hypothesis and conclude that IMR has a significant and strong positive impact on average number of children per woman. This result is in line with INET 2023, who found that some developed nations with higher IMR will result in higher TFR, possibly to the limited access to family planning. Next, for the third independent variable, which is LON-GDP, for the null hypothesis, the slope coefficient of LON-GDP is equal to 0, while the alternative is less than 0. GDP per capita has a significant impact on average of children per woman, TFR. As the GDP goes up, will result in reduce of TFR. From the multiple linear regression analysis table, we could see that the LON-GDP is not statistically significant with the p-value of 0.247. Hence, we failed to reject the null hypothesis at all level of significance. However, this result contrary with Lee et al. 2023 and Key et al. 2013, who found that a strong and negative association between GDP per capita and TFR due to high cost of children, changes in female roles, and quantity-quality trade-off. High cost of children because raising children becomes more expensive due to increased living costs and education expenses, which discouraging larger families. For the last independent variable, which is LONHEX, For the null hypothesis, slope coefficient of lone heads is equal to 0, while the alternative is less than 0. Lone heads has a significant impact on average number of children per woman, which is TFR. Increase in health expenditure will result in decrease the TFR. From the regression analysis table, we could say that lone heads is not statistically significant at all significant level because the p-value is 0.215. We don't have enough statistical evidence to reject the null hypothesis at the 0.1 significant level. This is contrary with Kim et al., who found a significant negative association between public health expenditure and TFR. The improved healthcare, especially for women and children, is proposed to contribute to lower fertility by reducing infant mortality rate, decreasing the need for insurance birth, increasing females' education, and workforce participation. Most people nowadays prefer to have a small family size instead of large size. So for the next part is discussion. So for the first question is, what happens to the slope coefficient, which is beta 1 hit, once the model is MLR instead of SLR? Discuss whether the model is suffering from omitted variable bias. So for this study, I choose my literacy as for my X1, which is my first independent variable. So as you can see, the slope coefficient of adult female literacy for SLR and MLR are negative 4.845 and negative 0.256 respectively, which the slope coefficient is increasing. When moving from SLR to MLR, the slope coefficient of beta 1 may change due to the inclusion of additional independent variables, which are IMR, longevity, and non-heads. The impact of this change depends on whether the new variables are correlated with the existing independent variable, which is literacy, and then dependent variable. For this study, we can see that all the independent variables are strongly correlated with each other because the correlation is above 0.7, plus minus 0.7. Okay, we can see that beta 1 in the SLR is suffering from omitted variable bias, leads to inconsistently estimate the regression because the dependent variable, TFR, is only influenced by the literacy. For the next question, do you think the independent variables together do a good job of explaining variation in the independent variable? Explain. To determine whether the independent variables collectively do a good job of explaining the variation in the dependent variable, we can evaluate several aspects of the regression output, which is for the first one is R squared. R squared 0.7831 measures the proportion of the total variability in the dependent variable explained by the independent variables. In this case, approximately 78.31% of the variation is accounted for. The adjusted R squared 0.77 adjusts the number of predictors in the model. Next, the ANOVA table provides an overall assessment of the model significance. The F statistic, which is 60.50, is significant with a very low p-value of approximately zero, suggesting that at least one independent variable contributes significantly to explaining the variation in the dependent variable. From the result of the hypothesis, we can see that IMR is statistically significant and contributes most impact on total fertility rate because the p-value is 0.01. So it is significant at all significant level. So I think the independent variables together do a good job of explaining the variation in the dependent variable. The individual coefficient and their significant levels provide insights into the specific contribution of each variable to the model. For the last question, do you need to add a quadratic function to the equation and justify? Right. Based on my study, I can say that I don't need to add quadratic function into the equation because all the explanatory variables don't have the maximum point or minimum point, also known as turning point for the dependent variable, which is total fertility rate. Furthermore, there were lack of theoretical justification about adding quadratic function into the model. Most of the studies shows linear association between explanatory variable and TFR. However, without a compelling practical reasons to suspect a non-linear relationship, it's generally recommended to start with the simpler linear model. In addition, the R-squared value in the model is 0.7831, which is considered quite high. This indicates that the current linear model is already explaining a substantial 78.3% of the variation in the dependent variable. If a quadratic term were essential, we are likely to see a much lower R-squared value. In summary, the high R-squared value and lack of theoretical justification suggests that current linear model is likely sufficient. That's all from me. Thank you.